All right, welcome back. We're going to solve another system of equations using substitution. So in this video, what I'd like us to consider is that solutions aren't always nice, neat integers like they have been in all the previous problems. This problem won't have a nice, neat integer solution for x and y. Quite often in real contexts in life, the intersection of two lines is not going to neatly land on some coordinates on your grid that happens to be 3 away from the x-axis and 7 away from the y-axis or something really neat like that. It'll be some weird rational number, some fractional number. Okay, so again, if we want to substitute, we need to have one of our equations be x equals stuff, x all alone, or y equals stuff, y being all alone. So as you can see, if we divide by 40, we'll get a single x. 5 divided by 40 is a fraction. Negative 23 divided by 40 is a fraction. So we'll end up with fractions. If we wanted to get y alone in this equation, we divide by negative 5, or by 5. 40 divided by 5 is 8, but 23 divided by 5 is still a fraction. Okay, so then let's think about our second equation. If we divide by 60, 60 is larger than 3 and larger than 5, which means we're going to get fractional results. If we divide by 5, 60 divided by 5 is 12, but 3 divided by 5 is 3/5. Again, we have a fraction. So we aren't going to have a really convenient thing happen here. So what we should do is just pick whichever one we think is nicest. I think that last one was pretty good because we only had one fraction, and it was a fraction with small numbers, 3 and 5. So let's solve this equation for y. So we'll move 60x to the other side by subtraction. That'll leave us with 5y. And then we want to get y by itself, so we undo multiplying by 5, divide by 5, leaves us with y. Negative 60 divided by 5 is negative 12, and 3 divided by 5 is 3/5. All right, so now we have this equation where y equals this expression. So we can take this expression and substitute it for y anywhere we want. We want to do that in the equation we didn't use to find this equation. So we'll put this expression in for y, and that will be 40x minus 5 times y. Y is this stuff, so negative 12x plus 3/5. That's our substitution. We substituted this expression for y, and then we finish our equation equals negative 23. Now we've got a single equation with one variable, and we can solve for that. So we'll distribute the 5, and we get 40x minus 5 times negative 12. So negative times negative is positive. 5 times 12 is 60. 5 times 3/5 is 3, but we're subtracting. Negative times a positive is negative. 5 times 3/5 is 3, and that's all equal to negative 23. We can combine our x's. There are 100 of them. We can move the 3 to the other side, add 3 to both sides, and we get negative 20. And to get x alone, we'll divide by 100. And that will be negative 20 divided by 100 reduces to negative 1/5. So that wasn't too bad. It's a fraction, it's negative. It's not a nice, neat integer, but there it is. X should equal negative 1/5, and we'll use that to see what y equals. We'll substitute negative 1/5 for x here and see what happens. So 60 times negative 1/5 negative 1/5, well, 60 divided by 5 is 12, and it's negative, so negative 12 plus 5y equals 3. Add 12 to both sides, and we get 5y equals 15. And if we divide y by 5, 5y by 5, we get y. 15 divided by 5 is 3. So, if we did that right, our solution should be negative 1/5, 3. We should confirm that in both of these. So we'll do 40 times the x value, negative 1/5, minus 5 times the y value, should equal negative 23. So we get 40 divided by 5 is 8, and it's negative. And we get negative 5 times 3 is negative 15. And that does indeed equal negative 23, so we've checked this equation. Now we should just double check for sure. If we substitute, do we get the right answer here? So 60 times negative 1/5 plus 5 times 3 should equal 3 if we are correct. So 60 times negative 1/5 is negative 12. 5 times 3 is 15. And negative 12 plus 15 is 3. Well, there we go. So it turns out we actually did have one convenient coordinate, but the other one was a fraction, and that's okay. That just means that the point that these two lines intersect at happens to be at negative 1/5, positive 3, and we're done.